So the sample proportion would be 0.68, and 1 minus that would be 0.32 over n, which is 2032, definitely big enough. So my margin of error would be 1.645 times the square root of 0.68 times 0.32 divided by 2032, and that gave me 0.017, and so we'd take 0.68 plus or minus 0.017, so I'd have to subtract it. And add it. And what would be the interpretation? I am 90% confident that the population proportion of youths who have a TV in their bedroom is between 66.3% and 69.7%. What would happen to those numbers if I went up in percentage of confidence? That interval would get broader. Now on this next one, I want to show you how we can do this in the calculator too. So we'll do it both ways. Okay. The Pew Internet and American Life Project conducted a poll between October 23rd and November 19th, 2006, in which a simple random sample of 935 teenagers between the ages of 12 and 17 were asked whether they participate in any form of content creation for the Internet. That's development of web pages, posting to blogs, and social networks. Of the 935, 598 reported that they participate in content creation. We're going to obtain a 95% confidence interval. So the first thing we need to do is, this time they did not give us p-hat. So let's think about that. We know the number that was surveyed, that's 935. And we were told that 598 participate in the content creation. Well, then that means we do 598 divided by 935 to get our proportion. That's that's 0.6395, so I'm going to go 0.64, so 64%. Now, we have to verify that our sample is large enough. So 935 times 0.64, is that going to be good? Yes. 935 times the opposite times that'd be 0.36. Yes, that's good. Critical value at 95%. We look back at our chart. The critical value is 1.96. So I need to come off to the side and do the 1.96 times the square root of 0.64 times 0.36 divided by 935. And then we're going to add and subtract that to 0.64. Here's what I'm going to show you on the TI. we're going to go to a 1 proportion Z interval. Oh, not the test. I'm sorry. I hit the wrong one. 1 proportion Z interval. Now it asks me what X is. X is the number who said they created the post. So it actually finds that percent for you. And then it asks you for the C level. So C level would be 0.95. This one is really nice when they don't give you your proportion. It actually finds it for you. And so my lower boundary is 0.6088 to 0.67035. So let's interpret the results. I am 95% confident the population proportion who create content is between, that'd be basically 61% and 67%. Now, could I use the calculator even if they give me the percent? I could. But this next example is another one that they don't give me the proportion for, so we're going to do the calculator again. Obtain a point estimate for the proportion. Oh, I'm sorry, I didn't read the example. A Harris Interactive poll conducted during January 2008 found that 944 of 17,048 adult Americans who do not have a tattoo believe that individuals with tattoos are more rebellious. Obtain a point estimate for the proportion of American adults without tattoos who believe that having a tattoo makes you more rebellious. So that's our p hat. That would just be taking that 944 out of 1748. So 944 out of 1748 is 0.54. Now verify that the requirements are met. They ask you to do that, then you would have to show that you check the sample sizes are large enough. 1748 times 0.54. Oh, that's that 944 that said yes. This is the 804 who said the other. Construct a confidence interval. I'm going to actually use the test so I can show how to use that again. It's a 1 proportion Z interval. There was 944 out of 1748, and we were using a 0.90. So that would be 0.52, so 52% to 56%. Changed it to 99%. Okay, so, whoops, stat. You can also go backwards. Same thing, but 0.99. That's 50.9 to 57. So notice that increasing my percentage of confidence increased the interval. So increasing the level of confidence increases the width. Okay, what if I wanted to figure out the minimum sample size needed? Alright, so I'm going to have to do a little bit of math here. Let's think. A researcher wishes to estimate with 95% confidence. So my Z, 95% confidence, is going to be 1.96. And if you're wondering how I get those so fast, I have this sheet of paper sitting right next to me, who have high-speed internet at home. 40% of the people in the previous study had high-speed internet at home. The researcher wishes to be accurate within 2%. So they want their margin of error to be 2%. Okay, 2%, 0.02. So remember, the margin of error is found by taking the z-score times p hat times 1 minus p hat divided by n. So I'm going to plug in what I know. Now I could rearrange the formula. You know what? I'm going to rearrange the formula for you. So you'll have a formula that you can use to find a minimum size. Okay, if I'm going to rearrange the formula, the first thing I'm going to do is divide by that z-score. Now, I need to undo the square root, so I'm going to square both sides. I should have given myself more room, but I did not. Did not plan ahead. Now, little known fact in algebra sometimes is that I don't like that n being on the denominator because that's what I'm trying to solve for. I want to reciprocate that fraction, so I can reciprocate both sides. Now it's going to be a little bit easier to solve for n, because all I have to do is multiply both sides by that p hat. So z divided by the margin of error squared times p hat times 1 minus p hat will give me my minimum sample size. So for this problem, I'm going to take 1.96 divided by 0.02 squared times 0.40 times 0.60. So 1.96 divided by 0.02 squared times 0.4, basically it's 0.4 times 0.6. And I get, that's going to, we don't want a 0.9 of a person, that's going to always round up to 2305. When you're getting a sample size, you always round